I have a dream that one day
Hi there everyone. Welcome to the third lesson on GPs. In this lesson, we want to deal with using the sum formula, and there are three techniques that we want to look at. These are finding the sum, then finding the number of terms, and using the general sum. In the first example on using the sum formula for GPs, it says determine the sum to 6 terms of, and we are given the series. So let's have a look at it. We can start by writing down what we have and what we need to find. We have the first term A, it's negative a half. We can find the common ratio R by taking term 2 divided by term 1. So here we have a fraction divided by a fraction. So we can multiply the numerator by the inverse of the denominator, and this comes to negative 2/3. We are also given n is 6, and we need to find S sub n, in other words S sub 6. So using the sum formula, S sub n is A into R to the n minus 1 and this is all over R minus 1, and we can substitute in our values. So S sub 6 is A into R, and we saw that R was negative 2/3 to the n, and n is 6. This is all over R minus 1. So negative 2/3 minus 1. And this we can work out on a calculator. So let's see what it comes to. And it's negative 0.27 rounded off to 2 decimal places. So let's look at your answer to this question. It says determine the sum to 5 terms of the following series, and we are given this geometric series. So writing down what we have and what we need to find. A is the first term, and that's negative 8. R, the common ratio, we can get by taking term 2 divided by term 1, and that's negative 2. N is given as 5. We have to find the sum to 5 terms. So we have to find S sub 5. So then using the sum formula, so S sub 6, or rather S sub 5, is equal to A into R to the n, and n is 5. And this is all over r minus 1. So negative 2 minus 1. And working this out on a calculator, and we see that our answer comes to negative 88. So S sub 5 is negative 88. Example 3b deals with finding the number of terms, and in the first question it says, consider the geometric sequence 3 plus 9 plus 27, etc. Find the number of terms that will give a sum of 1093. So let's have a look at it. We can write down what we have and what we need to find. The first term a is 3. We can get the common ratio r by taking term 2 divided by term 1. So we see that r is also 3. We are given the sum to n terms, and we need to find the number of terms that will give the sum. So we need to find n. We can use the sum formula. And we can substitute in our values. So S sub n is 1093. A, of course, is 3. R is also 3. And we need to find n. We can simplify the right-hand side a little bit. Now, we need to find n in this equation. So first we can get rid of the 2 here, or the fraction, by multiplying both sides by 2. So we have 1093 times 2, 2186, equals 3 into 3 to the n minus 1. We want to isolate n. We can divide the 3 into the 2186. And we're left with 3 to the n minus 1 equals 2186 divided by 3. I'm going to leave this as a fraction because we want to round off only the final answer. We can also take the negative 1 to the right-hand side. Now, this is an exponential equation where the unknown n is in the index, or is the power. So we're going to use logs. So we take the log on both sides. Now we're going to use the log rule that says the log of a to the m is m times the log of a. In this way, the n can be written in front of the log here. So n log 3 is equal to the right-hand side. We can divide the log of 3 into the right-hand side now. and find this on a calculator, and our answer comes to 6. We do have a slight rounding error because n must be a natural number, it being the number of terms. So the number of terms that will give a sum of 1093 is equal to 6. In the second question here it says, calculate the smallest integral value of n such that this sum is greater than 800. So let's have a look at it. We could start by multiplying the 40 into the brackets. So we have 40 plus 40 times 1,052 plus 40 times 1,052 squared plus all the way up to 40 times 1,052 to the n minus 1. This is clearly a GP, or geometric series rather, where the first term a is 40, and we're multiplying by 1,052 each time. So r is 1,052. We want n such that s sub n is greater than 800. So we need to find the value of n for which this is true. Then using the sum formula, we can plug in our values. So a is 40 and r is 1,052. Then 1,052 minus 1 is 0,052. This is s sub n, and it must be greater than 800. We can get rid of the fraction here by multiplying through by 0,052. So 800 times 0.052 is 41,6. So 41,6. We want to isolate n on the left hand side. So we're also going to divide the 40 into the right hand side. And I'm going to leave this as a fraction for now. Now we can take the negative 1 over. Now, this is an exponential equation where the unknown n is in the index or the power. So we're going to use logs. We're going to take the log on both sides. And now we can use the log rule that says the log of a to the m is m times the log of a. So using this rule, the n can go in front of the log. And now we can divide the log of 1,052 into the right hand side. Now note that here 1,052 is greater than 1. So the log of it will be positive, and hence the inequality doesn't have to switch around. So divided by the log of 1,052. So let's see what it comes to on a calculator. And it's 14,06. So n is greater than 14,06. Now, the natural number closest to 14,06 but greater than it is 15. So this means that n equals 15. To go back to the question, we needed to find the smallest integral value for n such that this sum is greater than 800. And we see that n comes to 15. So this is the smallest integral value for which the sum is greater than 800. Let's look at your answers to this question. In the first one it says, find the number of terms in the geometric series. And we are given the series, and we are also told that it comes to 127. So let's write down what we have and what we need to find. We have the first term a, it's 64. We can get the common ratio r by taking term 2 divided by term 1, and this is a half. We are also told that the sum to n terms is 127, and we have to find n, the number of terms. So we're going to use the sum formula. S sub n equals a into r to the n minus 1 all over r minus 1, and we can substitute in our values. A is 64, r is a half, and in the denominator here we have a half minus 1, which is negative a half. So this is S sub n, and it must equal 127. We can first get rid of the negative a half here, in other words the fraction, by multiplying both sides by negative a half. So let's see, 127 times negative a half is negative 63,5. We want to isolate n on the left hand side. So we can also divide by 64 on both sides, or into the right hand side. I'm going to keep this as a fraction for now. Now we can take the minus 1 to the right hand side. And we're going to use logs again. So we take the log on both sides. And we now can use this rule. The log of a to the m is m times the log of a. So we can write the n here in front of the log. And finally, we can divide the log of a half into the right hand side. So let's see what that comes to. And we see that n comes to 7. So n equals 7. So the number of terms in the series which will give 127 is 7 terms. So in the second question here it says, calculate the smallest integral value of n such that this series is greater than 150. So let's write down what we have and what we need to find. We have the first term a, it's 4. The common ratio r is term 2 divided by term 1. And this simplifies to 3 over 2. We are told that s sub n must be greater than 150. And we need to find n. So once again, we're going to use the sum formula. And we can substitute in our values. A is 4. R is 3 over 2. Now, r minus 1 is 3 over 2 minus 1. So 1.5 minus 1, which is a half. This is s sub n, and this must be greater than 150. We can get rid of the half here by multiplying both sides by a half. (150) times a half, of course, is 75. Now we can divide the 4 into the right-hand side. We can add 1 to the right-hand side. And we're going to use logs again. So we're going to take the log on both sides. Then, using the log rule, we can put the n in front of the log. Now we can divide the log of 3 over 2 into the right-hand side. Now, what's important to note here is that 3 over 2 is greater than 1. So the log of 3 over 2 will be positive, and hence we don't have to switch around the inequality. So it's the right-hand side then divided by the log of 3 over 2. This we can work out on a calculator. And our answer comes to 7,36, rounded off to 2 decimal places. So n is greater than 7,36. And the natural number closest to 7,36 but greater than it is of course 8. So n is equal to 8. So to go back to the question, the smallest integral value of n, such that this sum is greater than 150, is in fact n equals 8. Example 3c deals with using the general sum. It says, consider the geometric series, and we are given the series to n terms, and in A, we must find the nth term in simplest form. So let's have a look at it. Before we start on A, we can write down what we have. We have the first term A, which is 27. We can get a common ratio by taking term 2 divided by term 1. So this comes to a third. And just to note that the nth term is the same as the general term. So we're going to use the formula T sub n. So T sub n equals AR to the n minus 1. And we substitute in A and R. A is 27, R is a third. We can simplify this. 27 we can write as 3 cubed using prime factors. And a third we can write as 3 to the negative 1 using the rules of exponents. Of course, here we are using the rule 1 over a to the m equals a to the negative m. We can simplify further. So we have 3 cubed, and here we can multiply the powers. So we get 3 to the negative n plus 1, or 1 minus n. And of course here we're using the exponential law, a to the m all to the n is equal to a to the m times n. We can now add the powers because we are multiplying and the bases are the same. So we can add the powers. 3 plus 1 is 4. So we get 3 to the 4 minus n. And this is in simplest form. In B it says, prove that the sum of the series is given by this equation. This is another way of asking us to prove that the general sum comes to this. So we're going to use a sum formula. So S sub n equals A into R to the n minus 1 all over R minus 1. So over R minus 1. And we're going to substitute in the values of A and R. A is the first term, it's 27. R we saw was a third. So a third to the n minus 1. Then in a denominator, we have R minus 1, which is a third minus 1. In other words, negative 2/3. We're going to simplify this. 27 is 3 cubed using prime factors. And I'm going to write a third as 3 to the negative 1. Now, a third to the n, or to the power of n, can be written as 3 to the negative 1 to the n. And here we're using the law of exponents that says 1 over a to the m is a to the negative m. And this comes to 3 to the negative n when we're multiplying the powers. And here we are using the exponential law, a to the m all to the n equals a to the m times n. So then we can write a third to the n as 3 to the negative n. So 3 to the negative n, and it's minus 1 all over negative 2/3. We can multiply the 3 cubed into the brackets, and in adding the powers, because the bases are the same, it's 3 to the 3 minus n, 3 plus negative n, and in minus 3 cubed in the numerator, and this is all over negative 2/3. Now we are dividing by a fraction, so we can multiply by the inverse of it. So basically the numerator, multiplied by the inverse of negative 2/3, in other words negative 3 over 2. Now I'm going to multiply only the 3 into the brackets here. So then adding the powers, of course this is 3 to the 1 here. So adding the powers, I get 3 to the 3 minus n plus 1. In other words 3 to the 4 minus n. And adding the powers here, I get 3 to the 4. And of course we still have negative a half as well to multiply with. Now we're going to multiply the minus into the brackets. So I'm going to write the 3 to the 4 first. In other words, negative 3 to the 4 times negative 1 is positive 3 to the 4. And then I'm going to multiply this number by negative 1 as well. So it becomes negative 3 to the 4 minus n. And this is all over 2. And we have proved what we were required to prove. If you look at the question, 3 to the 4 minus 3 to the 4 minus n over 2. So this is then the equation for the general sum, S sub n. In the third part of this example, it says determine S sub 50. In other words, the sum to 50 terms. This is quite easy now that we have the general sum, because all that we do is we make n equal to 50 in this equation. So then S sub 50 will equal 3 to the 4 minus 3 to the 4 minus 50 all over 2. And this we can work out on a calculator. So 3 to the 4 minus 3 to the negative 46 divided by 2. And this comes to 40,5. So the sum to 50 terms then is 40,5. Let's look at your answers to this question. In the first one, we are given this geometric series, and we have to prove that the sum to n terms is given by this equation. So let's start by writing down what we have. We have the first term a, it's 8. We have the common ratio r, it's 4 over 8, which is a half. And now we need to prove this formula. And we're going to use the sum formula. So S sub n equals a into r to the n minus 1 all over r minus 1. We plug in a and r. So a is equal to 8. R is a half. This is all over r minus 1. So a half minus 1, which is negative a half. We are dividing by a fraction, so we can multiply by the inverse. In other words, 8 divided by negative a half. So 8 divided by negative a half is the same as 8 times negative 2 over 1. And this, of course, is negative 16. So we have negative 16. And then a half to the n, I'm going to write as 2 to the negative n using the rules of exponents. Now we can multiply the negative 16 into the brackets. So negative 16 times negative 1 is 16. And in multiplying the 2 to the negative n also by 16, or negative 16. Now we can use prime factors of 16 here. So 2 to the 4. And here we are multiplying and the bases are the same. So we can add the powers. So 4 plus negative n is 4 minus n. Let's look at 1.2. It says how many terms will give a sum of 127 over 8. So S sub n equals 16 minus 2 to the 4 minus n. This equation is the general sum. And we just make S sub n equal to 127 over 8. So 16 minus 2 to the 4 minus n is 127 over 8. And we need to solve for n. So we can first take the 16 to the other side. So negative 2 to the 4 minus n is 127 over 8 minus 16. I want to get rid of the negative here, so I'm going to multiply both sides by negative 1. So 2 to the 4 minus n equals 16 minus 127 over 8. We're going to use logs. So we take the log on both sides. And now we use the log rule that says the log of a to the m is m times the log of a. So this power here can be written in front of the log. So hence 4 minus n times the log of 2 equals the log of the right hand side. Or equals the right hand side here. And now we can divide log 2 into the right hand side. So 4 minus n equals the right hand side divided by the log of 2. So on a calculator, and our answer comes to negative 3. Now we can solve for n. So negative n equals negative 3 minus 4, which is negative 7. And hence n is 7. Let's look at the answer to the second question. We have a geometric series. And they tell us that S sub 4, the sum to 4 terms, is 7.5. S sub 5, the sum to 5 terms, is 15.5, and S sub 6, the sum to 6 terms, is 31.5. It says determine in terms of n the sum to n terms of the series. So we are asked to find the general sum given this information. We're going to start by writing S sub 4, S sub 5, and S sub 6 as improper fractions. So 2 times 7 plus 1 is 15 over 2. 2 times 15 plus 1 is 31 over 2. And 2 times 31 plus 1 is 63 over 2. Now, in order to write down the general sum, we need the values of a and r. So here they say S sub 4 is 15 over 2. And S sub 5 is 31 over 2. Now, S sub 5 less S sub 4 will give us the value of the fifth term. So the sum to 5 terms less the sum to 4 terms gives us the fifth term. So then we have the values of S sub 5 and S sub 4. So 31 over 2 minus 15 over 2 must give us T5, which is AR to the 4. So 31 over 2 less 15 over 2 is of course 16 over 2, which is 8. So AR to the 4 equals 8. And we're going to call this equation 1. Then similarly, S sub 6 less S sub 5 will give us T sub 5. So the sum to 6 terms less the sum to 5 terms will give us the sixth term. So then S sub 6 is 63 over 2. So 63 over 2 less S sub 5, which is 31 over 2. So 31 over 2 equals T sub 6, which is AR to the 5. AR to the n minus 1. And here, of course, we have then that AR to the 5 will equal 32 over 2. This comes to 32 over 2, which is 16. And we're going to call this equation 2. Now we're going to solve simultaneously. So equation 2 divided by equation 1 will be AR to the 5th divided by AR to the 4. And this equals 16 divided by 8, which of course is 2. Here the a's cancel. And R to the 5 divided by R to the 4 will be R. So R is equal to 2. Now that we have R, we can plug it back into, let's say, equation 1 and get A. So substitute R equals 2 into equation 1. Equation 1 says AR to the 4 is 8. So A multiplied by 2 to the 4 equals 8. And we can solve for A. 2 to the 4 is 16. So 8 divided by 16 is a half. So A is a half. Now, remember that we have to find the general sum. And we now have the values of A and R. So we're going to use a sum formula. So S sub n is A, which is a half, into R, which is 2 to the n, R to the n, minus 1, all over R minus 1. And of course, R is equal to 2. So 2 minus 1. Yeah. And we can write a half as 2 to the negative 1. 2 minus 1 in the denominator, of course, is 1. And now we can multiply the 2 to the negative 1 into the brackets. And we get 2 to the, adding the powers, minus 1 plus n is n minus 1. And, of course, multiplying 2 to the negative 1 by negative 1 as well will give us minus 2 to the negative 1. We could also write this as a half, of course. So we should really do that. Write the answer with a positive power. So it's 2 to the n minus 1 minus a half. And this is the equation for the general sum which we needed to find.